Okay guys, so this is going to be the beginning of our unit over moles, percent composition, and empirical formulas. So what you're going to need for the next few lessons are going to be your periodic table and a calculator. Now I know most of you don't have a graphing calculator, but I'm going to have to individually show you how to put this stuff in the calculator for Avogadro's number. Okay, so what we're going to do is Avogadro's number is 6.02 times 10 to the 23rd. So anytime we have a large number we're trying to use times 10, I do 6.02, okay? And then I'm going to hit second comma. The capital E stands for times 10 to the power. So, and then I hit 23. So that's how I'm going to enter Avogadro's number when we're using it in our notes. Some of your calculators, like if you're using like a TI-34 or I think it's a 36, they have the EE key. You might have to use second x to the negative 1, or it might have an EE key towards the bottom. If you're using like a Casio, they have a times 10 to the N button towards the bottom. So I'll have to individually help you make sure that we're putting our numbers in the calculator correctly. Okay, so a mole is a word used to represent a quantity of something. In Latin, it means the amount of a substance. Okay, we're going to be dealing with things called representative particles. So representative particles refer to atoms, ions, molecules, or formula units. Okay, so a mole is pretty much a conversion factor. So 1 mole is equal to 6.02 times 10 to the 23rd representative particles, which means that this is going to be atoms, molecules, ions, etc. But we're pretty much just going to be dealing with atoms or molecules. Okay, Avogadro's number is 6.02 times 10 to the 23rd RPs. Now, 1 mole of a unit is equal to the formula weight. Okay, so we're going to talk about how to do the formula weight. Now, I want you to write something very, very important on the top of your notes or in your notes. So we're going to write, when I see grams, I use the formula weight. Okay, we'll talk about what that means in just a second. When I see atoms or molecules, I go through Avogadro's number. Okay. Some people call it Avogadro's number, but we're going to say it correctly. Avogadro's number. Okay. So this strategy is going to help you do these types of questions. They're pretty much just dimensional analysis questions. Okay. Our first examples are going to be dealing with formula weights. So molecular mass, formula weight. If I say the weight of a compound, it's the same thing. So calculate the molecular mass of benzene, C6H6. So I'm going to count how many carbons I have. I have 6. And how many hydrogens do I have? Well, I got 6 also. Now, to get the molecular weight, you're going to go to your periodic table. Now, carbon weighs 12. We're going to round up to the closest whole number. Okay, so it's 12. And hydrogen has a mass of 1. Okay, so we're going to fill that information in. So 12 and 1. So 6 times 12 is 72. And so we add them together, so it weighs 78 grams or AMUs. Okay, and AMU stands for atomic mass unit. We're going to be using grams a lot, so I mean, it's pretty much the same thing. So 1 mole of a substance is equal to its formula weight, okay, in grams. Next one, find the formula mass of magnesium nitrate, MgNO3 Okay, so I'm going to count mg's. I have 1 mg. Mg weighs 24 from our periodic table. 24. Nitrogens, I have 2 nitrogens. And nitrogen weighs 14 from our periodic table. Oxygens, I have 6. And oxygen weighs 16. Okay, like that. Okay, so I'm going to multiply these together and add down. So 24 plus 28 plus 96 comes out to be 148. 148 grams is your, or AMUs, however you want to do it. Okay, so those are pretty easy. Most people have a really easy time with getting these questions right. Those will be on your test. So let's get into some mole calculations. Okay, so calculate the number of moles found in 538 grams of C6H12O6, which is glucose. Okay, glucose is produced from photosynthesis. You take CO2 plus water, you get glucose plus oxygen. Okay, so what I do is I start with my grams. And I do it over 1. Like that. Now, anytime I see grams, I have to go through the formula weight. Okay, so the formula weight of this, we're going to go out to the side. Carbon has, we got 6 and carbon weighs 12. Hydrogens, we got 12 and hydrogen weighs 1. Oxygen, we got 6 and oxygen weighs 16. So we're going to add down and we should get 180 grams. Okay? Now, from when we did dimensional analysis, grams have to cancel with grams diagonally. So we say 180 grams of glucose gives me 1 mole of glucose. Okay, and then our units should cancel diagonally, always, like we did in dimensional analysis. Okay, so we're going to do 538, and we're going to divide it by 180. Okay, and you get 2.99 moles of C6H12O6. Now, a couple things. You can't abbreviate moles and molecules. They're not the same thing. So we got to write this stuff out. The actual abbreviation for for mole is MOL. Okay, so one other letter is not going to do you any sort of favor. But your setups need to be exactly like mine. This formula weight stuff needs to be set up exactly like mine, or your life's going to be very miserable on the next set, because that's how I'm going to teach it. So make sure, that's why we spent some time on dimensional analysis. I need to see setups just like this. Okay, next example problem. It says, how many glucose molecules are there in 5.23 grams of glucose? Okay, so 5.23 grams of C6H12O6 over 1. Now I'm going to go back up to the top. Anytime I see grams, I have to go through the formula weight. So my formula weight, I'm going to use the same one for this series of examples, is 180 grams of C6H12O6 to 1 mole of C6H12O6. Okay, so 1 mole is equal to the formula weight. Now, what is the question asking? Well, it's asking how many glucose molecules. So anytime I see atoms or molecules, I have to go through Avogadro's number. Now, Avogadro's number is this 6.02 times 10 to the 23rd. So 1 mole has to cancel on bottom. And we got 6.02 times 10 to the 23rd molecules of C6H12O6. Now, we know what an atom is, and we know what a molecule is. An atom is something that's all by itself. A molecule is whenever you have more than one element in there. Okay, so this is going to be a molecule, C6H12O6. Okay, so grams will cancel with grams, moles cancel with moles, and we're left with molecules. So we're going to multiply across the top and divide by the bottom. So we're going to do 5.23 times 6.02 times 10 to the 23rd, and we're going to divide it by 180. And you should get 1.75 times 10 to the 22nd molecules. Of C6H12O6. Okay? So when it comes time, when we get to this lesson, I'm going to individually show you how to put this in the calculator. If you're not getting the same answers that I am, then we need to see what you're doing wrong in the calculator. Next example says, how many carbon atoms are there in 3.2 moles of glucose? So we write our given over 1. Okay, so we're trying to go to atoms. So anytime I see atoms or molecules, I have to go through Avogadro's number. That's what my rule says. Okay, so 1 mole is equal to 6.02 times 10 to the 23rd. And we're dealing with molecules because this is a molecule. Okay, now the question is asking how many carbon atoms are there in this. Okay, so in 1 molecule of glucose, which is C6H12O6, I have 6 atoms of C. Okay, so what we're going to do is we're going to multiply all those numbers together. There's nothing to divide. My units cancel diagonally. Moles cancel with moles. Molecules cancel with molecules, and I'm left with atoms. So 3.2 times 6.02 times 10 to the 23rd, and then times 6. And you should get 1.16 times 10 to the 25. And this is going to be atoms of carbon. Now, 2 things. Make sure you go at least 2 decimal places on this stuff. Make sure you don't forget your exponents. That E means times 10 to the power. We do not write E on our paper. I will count everything wrong on your paper if you write E. Okay? So, in the next video, we're going to do a lot more example problems. I think I have 15 example problems. This is the hardest part of this unit is moles. So I want to spend some more time going over this slowly, do some more example problems. So if you have any questions, feel free to reach out. Thanks, and have a good night.